for our last video, we're going to look at the cotangent graph. So we're going to use the tangent values to look at what the values for cotangent will be. So when we look at the 0 radians, this middle part, where tangent was 0, our reciprocal would be 1 over 0. So your cotangent would be undefined. So you actually have your first asymptote, or one of the asymptotes, located on that y-axis. At pi over 4, it's 1, so the reciprocal of that would simply just be 1. So again, setting it up the same way I did before with 2 pi, pi over 2, and 3 pi over 2, right? So at pi over 4, it's 1. So notice how after the first asymptote, you're not going low, you're actually going to a higher spot above the x-axis. And then at pi over 2, where your tangent is undefined, the reciprocal of that would be 0. So at pi over 2, cotangent is 0, where tangent was undefined. At 3 pi over 4, directly after that, again, -1. So you see you're going low. Whereas with tangent, you were rising left to right. Now you're falling left to right. Then at pi, we have 0. The reciprocal of that, again, is undefined. So we still have asymptotes every pi radians away from each other. The difference is that they're located at just different radians. So your cotangent graph is going to be falling. So it almost looks like a reflection of the tangent graph. Not only is it a reflection of the tangent graph, it's a shift over pi over 2 from the tangent graph. So it's kind of like our sine and cosine graphs being pi over 2 away from each other. So at 3 pi over 2, again, you have 0. And it's going to follow the same pattern. Whoops. Of falling. And then again, at 2 pi, you have an undefined value. So every pi, 2 pi, coterminal angles of that, you have an asymptote for cotangent. So cotangent actually has the easier asymptote equation. So here's 2 periods. So the asymptote equation, let's start with the period. The period is still pi, just like tangent. Okay. And then the asymptote equation, since we have one located at 0, that makes it easy, but they still occur every pi radians away from each other. So pi times n would be your asymptote equation. So any horizontal transformations I would apply to this one as well. Okay, so that's what the cotangent graph looks like. Very similar to the tangent graph. Okay, we're going to try an example in class tomorrow, but just to kind of get you started, if we look at the asymptote, the original is x equals pi times n. Again, this makes it easier to graph. If I take my horizontal transformations, right, 2 times pi over 2 is pi. So when I factor out a 2, I get x plus pi over 2. I'm going to apply my shrink. So I'm going to multiply by 1/2. And then I'm going to apply my shift. So I'm going to go left pi over 2. So my new asymptote equation is going to be pi over 2 times n minus pi over 2. So now I have an asymptote located at negative pi over 2, and then every pi over 2 radians is a new asymptote. And that makes a lot of sense because your period is pi divided by 2 because of that shrink. So we'll look at what this graph looks like in class. So go back, reflect, ask questions if you need to, but that's it. About less than 15 minutes to fill that out. And again, come with questions on Monday. Have a good rest of your weekend.